this would be the last case we consider under the static designs. So let's have 4 factors in this case, where factor A has 4 levels while other factors, that is B, C and D, they are at 2 levels. So this is again a case of mixed levels, but here we will have to accommodate a higher level factor in a design layout for factors with lower levels. This technique is called the collapsing technique, and in this case also we will study only the main effects, no interactions. And the calculation, the initial calculation is the same. Degrees of freedom would be 6. The total number of experimental runs would be 1 plus 6, that is 7. And the nearest orthogonal array that we would end up selecting is L8, that allows for 7 factors at 2 levels. Now, a new thing to note is that when a factor has 4 levels, like in this case, factor A has got 4 levels, it is represented by 2 nodes and an edge joining them. And in the standard array, 3 columns are used to represent a 4-level factor. So this is how the required linear graph would look like in this case. Now, this is the standard linear graph for L8, and then as a next step, we modify the standard linear graph to match it with our required linear graph. Now coming to the factor allocation, since factor A has 4 levels, it will be represented by the first 3 columns, column 1, 2 and 3. And other factors B, C, D would be assigned to the next columns in that order, that is column 4, 5 and 6. This is the standard layout for L8 array. Now the tricky piece is how we arrive at the levels for factor A. Factor A, as we said, has 4 levels and will be represented by 3 columns, that is column 1, 2 and 3. So what we do is that we group the similar factor levels in column 1, 2 and 3 and assign them as 4 unique levels for the factor A. So that completes our set of 5 cases where we saw common situations which we may encounter during the application of static Taguchi's designs. The next important phase is the parameter design phase, when we conduct the experiments, record the response and analyze the results. One of the key concepts in the upcoming phase is the signal to noise ratio. It actually helps to locate the factors and their levels, which will result in least variation, and also helps to identify that factor which will help to shift the mean to the target value without changing the state of least variance.